breaking the wall of cooling and heating. Guilherme Fidelis Peixer, Falling Walls Lab, Brazil.
What if I told you that one of the technologies that have one of the major contributions for global warming is present on the lives of most of us, but we might not even be aware of it? Well, hopefully the title of my presentation hasn't blown out my surprise, but I'm talking about cooling, heat pumping, and air conditioning systems, which currently account for roughly 17% of the global electricity consumption and 10% of the greenhouse gas emissions. This is really bad, but it's about to become much worse. First, from a demand perspective, we do have projections that the number of air conditioning units will triple by 2050, which will soar the demand for those systems. Second, from a technological supply demand, the systems operate with what we call mechanical vapor compression of a volatile fluid, which relies on the compression and expansion of a fluid to generate the cooling effect. These fluids, they have what we call a global warming potential, which is thousands of times that of CO2 when they are leaked to the atmosphere, and that causes a huge problems in terms of global warming. For that, this growing demand for air conditioning is considered to be one of the most critical blind spots in today's energy debate. Well, to tackle that issue, we have several solutions for that. For instance, improving this mechanical vapor compression systems, or even trying new fluids. However, this technology is 100 years old and is immature. And we have already tried fluids that were toxic, flammable, and that have caused other environmental issues, which we could not predict at the time, such as the ozone depletion caused by the CFCs. For that, we developed a new technology, a new prototype, which is called magnetocaloric refrigeration. And the main principle is that instead of compressing and expanding a fluid, we magnetize and demagnetize a solid. This technology has two major advantages. First of all, as we are employing a solid-state refrigerant, there's no risk of leakage of harmful refrigerants to the atmosphere. Second, from a thermodynamic perspective, it is more efficient to magnetize and demagnetize a solid than it is to compress and expand a fluid. At Polo, at the Federal University of Santa Catarina, Brazil, we have developed and reported the first prototype to demonstrate the technology and achieve the temperature span for air conditioning operators, which can be used either for cooling or for heating in a relevant environment, which is a calibrated calorimeter that emulates both the cold and heat reservoir sources. This technology has employed artificial intelligence both for its design and also for its predictive control, and we have a patent pending for this prototype. And this is how we break the walls of cooling and heating. Thank you very much.